Hi friends, in this video we shall learn about current electricity related to Gpstr exam 2022. So in the previous class we have already started with maths and few physics classes. Please check the description box for those videos link. And before that, all those who have not yet subscribed to our channel, please do subscribe and press the bell icon and also press all button so that you will get all the notifications of the videos upload here related to Gpstr exam. And these topics will also be helpful for all those aspirants, those who are preparing for TET exams, Central TET, State Board TET, along with CET exams. Okay, let's move into the topic now. This current electricity is also one among the important topics. So there are many questions even for multiple choice. For descriptive type answers also the questions are asked. Okay, concepts are easy, but a little bit we have to concentrate more here. Okay, let's see about current electricity. We have already learned about charge. What is charge? It's nothing but flow of electrons, positive and negative charges. Electrons will have negative charge. The positive charges constitute current, we say. So when we speak about current, electric current, it's defined as rate of flow of charge. Okay, this word rate defines timing, at what time it flows. Okay, rate of flow of charge is called current, and it is expressed in the formula I is equal to Q by T, where Q stands for charge, T stands for time. Okay, about charge already we have learnt in previous class, and we'll focus on important points here. Okay, so now, and current is a scalar quantity. Why it is a scalar? So we have learnt about scalar quantities also in the previous class. I repeat here, scalar quantities have only magnitude. It does not have any direction. Okay, so you take a conductor. If it is straight wire, current flows in this direction. If you make the same as circular in path, this does not have direction, but still current flows. You make a zigzag with the same conductor, still current flows. So it does not have any particular direction. So current is a scalar quantity. Clear? Now SI unit of current is ampere. You see, when I wrote here, it's written ampere with small letter A. When you express any SI unit from the name of a scientist, the first letter should be small alphabet, not the capital. Whereas when you write as a symbol, it should be a capital letter. But when you write as a term, as a name, it should be a small letters. This is also one among the rules to write the SI units. Okay, using the above formula of current, we can write the unit of this current. We can derive the relation between ampere and coulomb. So for SI unit of current is ampere, for charge it is coulomb, for time it is second. Hence we can write 1 ampere is equal to 1 coulomb per second. So coulomb per second is the SI unit of current. How do you define 1 ampere of current? It is defined as the current which flows in a conductor when 1 coulomb of charge passes in 1 second is called as 1 ampere. And there are smaller units of ampere also, milliampere. When we write milliampere, you check with this, you see milli, m, small letter m, a, this is milliampere. Okay, how much is 1 milliampere comparing with ampere? 1 milliampere is equal to 10 to the power of minus 3 ampere. Next, for microampere, it is we write like this: micro ampere, and 1 microampere is equal to 10 to the power of minus 6 ampere. This we will be using in numericals, okay? Please note down. Okay, clear about current. And other basic points are current always flows through a metal, preferably. Metals constitute free electrons in an easy way, so they flow through the metals easily. So when we write like that, we can also write charge Q is equal to number of electrons, N into E, number of electron flows, we can write. Okay, now we shall learn the concept of potential difference. Before that, let's learn what is potential. This potential is different from potential difference. Okay, potential at a point is defined as work done per unit charge, W, work done per unit charge in bringing a positive test charge from infinity to that point. Okay, I repeat, potential is defined as amount of work done per unit charge in bringing a positive test charge from infinity to that point. Okay, and it is expressed by a formula V is equal to W by Q, and it's also a scalar quantity. It has only magnitude, no direction for the potential. Okay, and the SI unit of potential is volt. 1 volt is equal to joule per coulomb. You see, we can get from this formula. V stands for potential and SI unit of potential is volt, so we write 1 volt. And for W, W stands for work done, SI unit of work is joule, Q stands for charge, SI unit of charge is coulomb. So when you take this C to the numerator, it becomes per coulomb. So 1 volt is equal to 1 joule per coulomb. Okay, now we shall move to potential difference. So how do you define potential difference? It is nothing but the amount of work done in bringing positive test charge from one point to the another point. Here we have taken point A and point B. For potential difference, the amount of work done per unit charge in moving a positive test charge from one point to the other point. So we have considered 2 points here, A and B. So from this A to B, we are bringing the test charge. Hence, potential of V of A minus V of B is equal to W by Q. These two are same. Okay, only thing here, we write the difference of those two potentials. Hence, it is called as potential difference. It is also called a scalar quantity, and unit of potential difference is also volt as that of potential. SI unit of potential is volt, SI unit of potential difference is also volt. Symbol is V. Cleared? Easy concepts, right? Okay, these are the very basic concepts. Okay, next we shall move to electrical resistance. Resistance, how do we define this? It is nothing but the obstruction offered to the flow of current by the conductor is called as resistance. Suppose you take a conductor. If this is a conductor, through this from A to B current is flowing, let us take. So while flowing, there may be so many obstructions in the flow of current. Who is offering the resistance? The disturbance. Conductor is offering the resistance or obstruction. So that obstruction offered to the flow of current by the conductor is called as resistance. SI unit of resistance is ohm. So here also the first letter O, small letter O, H, M, and symbol is this. Okay, and 1 ohm is equal to 1 volt per 1 ampere. We know the formula for Ohm's law. V is equal to IR. We'll be learning now. I into R. So when you make R subject to the formula, V by I we get. So V by I, that is volt by ampere. 1 ohm is equal to 1 volt per 1 ampere. Now let's learn about Ohm's law. This law is given by a scientist named Ohm, hence we call this as Ohm's law. And the general expression of Ohm's law is V is equal to IR. V stands for potential difference, I for current, R for resistance. And according to Ohm's law, the current flowing through the conductor is directly proportional to the potential difference applied across its ends. Okay, that is I directly proportional to V. Current flowing in a conductor is directly proportional to the potential difference applied across its ends, provided that the physical conditions like temperature, pressure remains constant for that conductor. So this is the statement of Ohm's law. Okay, hence we bring this V to the denominator, I to the denominator of the right hand side. So we write V by I is equal to constant. Okay, that constant we represent by letter R, where R stands for resistance, and rearrange this, cross multiply this, V is equal to IR. So this is the general expression for Ohm's law. Suppose if you consider current through this conductor is 1 ampere, hence we get V is equal to R. Potential difference is equal to the resistance applied. And there are some limitations of Ohm's law also, as we told here earlier. Ohm's law is obeyed when the temperature of the conductor remains constant. It should not vary for the particular conductor. Hence only Ohm's law is applicable, or Ohm's law is obeyed for that particular conductor. And there are a few related topics also for this. Quickly let me tell you about that. It's about ohmic resistors and non-ohmic resistors. Okay, what are ohmic resistors? The resistors which obey Ohm's law are ohmic resistors. The resistors which does not obey Ohm's law are called non-ohmic resistor. So we give examples for ohmic resistors. Usually the metallic conductors like silver, aluminium, copper, iron, all these are ohmic resistors. Non-ohmic resistors contains solar cell, LED, junction diodes, sometimes the transistors, of course, filament of the bulb. All these are non-ohmic resistors. Even though they have not mentioned those in this topic, you just have a glance of those ohmic and non-ohmic resistors. And speaking about the graph obtained by ohmic and non-ohmic resistors, if we draw IV graph for metallic conductor, so it will be a straight line. If you find like this straight line IV graph, it's for ohmic resistors. Suppose you get a curve like this. If you don't have the straight line for IV graph, this represents non-ohmic resistors. So these are the points for ohmic and non-ohmic resistors. Since we are focusing only on the syllabus of the Gpstr exam, we are moving according to the syllabus only. Okay. So meanwhile, here and there, if it is important also, we will have a glance of that. Next, conductance. Okay. What is conductance? The reciprocal of resistance is called as conductance. Reciprocal of resistance, that is 1 by R. And the conductance SI unit of conductance is per ohm. Or it can also be written as Siemens. Okay. This is also have a glance of this. So while learning about Ohm's law, here let me also tell you about the factors affecting resistance of the conductor. Factors affecting resistance of the conductor. Okay, remember. So it depends on material of the conductor. Resistance depends on material of the conductor. It means the what type of material you choose for the electron free flow. Whether you choose a metal or you choose a non-metal or a semiconductor, whether it's a good conductor or bad conductor of electricity, like that. So always for the good conductor, resistance is less, isn't it? So resistance decreases when you choose the good conductor. Other metals, for metals resistance is less. So that's the first point for the factors affecting material, factors affecting resistance of the conductor. Second, it depends on length of the conductor. Resistance depends on length of the conductor. If the length is more, resistance is also more. If there is a short length conductor you choose, resistance is less. So we can write here R directly proportional to L. Okay, resistance depends on length of the conductor. When length increases, resistance also increases. Next, it also depends on thickness of the conductor. Resistance depends on thickness. Resistance is inversely proportional to 1 by A. A stands for area, so that's nothing but the thickness of the resistance. So if it is a thick conductor, you choose a thick wire instead of a thin wire. If you choose thick wire, resistance is less. If you use a thin wire, resistance is more. Okay. Hence we represent like this: resistance is inversely proportional to 1 A, normal area of cross section. Okay, fourth point is resistance also depends on temperature. Okay, resistance of the conductor increases with increase in the temperature. Note down this point, it's important. For the conductor, resistance increases when we increase the temperature of the conductor. Okay, you can choose any good conductors like aluminium or copper, or those conductors. Okay, the random electron motion will be more as you increase the temperature of the conductor. Cleared? Okay. Let's move to the concept of resistivity. Resistivity, this term is also referred as specific resistance. Remember this, specific resistance. So let's learn about specific resistance. Specific resistance of a material is the resistance of the wire of that material of unit length and unit area of cross section. It means in a simple terms to say that you consider a conductor. To calculate the resistivity of this material, we need to require like length of the conductor and area of cross section. Applying this along with the resistance, you can calculate the specific resistance. Okay, so as already we have learned that resistance of the conductor is directly proportional to the length of the conductor, and resistance is also inversely proportional to the area of cross section. Writing them together, we get R directly proportional to L and inversely proportional to A. Removing this proportionality constant, we insert a constant rho. This is called as rho. Okay, where this rho is called as specific resistance of the material or resistivity of the material. And rearranging this formula to make resistivity as subject to the formula, rho is equal to Ra divided by L, where rho is resistivity. SI unit of resistivity is ohm into meter. Ohm meter is the SI unit of resistivity. And this resistivity is different for different material or different substances. For example, if you consider different metals, silver, aluminium, copper, iron, some alloys, insulators, if you compare semiconductors, this resistivity of the material is different for different substances. And these points are very important. Okay, listen carefully. In case of metals, when you increase the temperature of the metals, resistivity also increases. For metals, the resistivity of the metal increases with raising the temperature. But for semiconductors, when the temperature increases, resistivity decreases. Note down this point. For semiconductors, when the temperature increases, resistivity decreases. And this resistivity does not depend on shape and size of the conductor which you choose. Okay. And here there are three more important points related to this resistivity. The resistance in normal term. If the length, you take a particular conductor, okay, if the resistance is increased, in case of how it changes, whether it depends on the length, how it changes the resistance. Let's see that. If the length is doubled, you take 1 meter wire and check out with the resistance and double the length. Instead of 1 meter, you take 2 meter conductor. The length is doubled, area will be halved. If the same material, the length is doubled, the area of cross section will be halved, decreased. It doesn't mean that you are adding another wire. No, that doesn't mean. You are just stretching the wire. Instead of 1 meter, you are stretching it to 2 meter. That's the meaning. Hence only area will be halved. Okay, the same wire is stretched. If the length is doubled, then A will be halved, and hence resistance will increase 4 times of its previous value. Then if the length is increased 3 times, if it is thrice increased, the resistance will increase by 9 times. Suppose if the length is half, what do you mean by that half? Take 1 meter wire, you just fold it into half meter and half meter, you fold it into 2 halves. So this is length is halved, area is doubled this time, and the resistance is decreased by 1/4 of the previous value. So these points it will be asked for multiple choice questions. Okay. Next, one more small topic, that is conductivity. Conductivity is defined as reciprocal of resistivity, is called as conductivity. Whereas we write for resistivity as RA by L, for conductivity L by RA. And SI unit of conductivity is per ohm per meter. It is expressed in this way as symbol. There are a few points to be noted while choosing the material of the wire for electrical connection purposes or for daily uses purpose to make the appliances. Let's see what it is. Okay, while choosing the wire for electrical connections, that particular wire should be of negligible resistance, means the disturbance obstructions must be less, then only it can be the output will be more, there will be less loss of energy. Okay, especially we can use copper and aluminium metals. The wires made up of copper and aluminium whose specific resistance will be very small, and we can use. Of course, when we compare this with silver, silver specific resistance is less only, but it is of high cost. We cannot use silver wires for conducting electricity, right? So we can use, this is cheaper material and of negligible specific resistance wires. Then for standard resistors, in case of resistors, we require resistance. Hence, we can use the material which is having high in resistance. Example, manganese and constantan. These type of wires will have more resistance and it serves the purpose in a better way. Next, in case of fuse wire, these questions are repeated in some competitive exams, even in TET also. Fuse is made up of alloy of lead and tin. This alloy will have low melting point and rho resistivity is more for fuse wire. Okay, I repeat, fuse is made up of alloy of lead and tin. It's having low melting point and specific resistance is more. So in case of copper and aluminium, specific resistance is comparatively it will be less only. Okay, but in case of alloy and lead and tin is more. So this what serves its purpose? It will permit the current to its safer limit. So consider this is a fuse here. So through this the current has to flow. So it will permit some certain safe limit. But when the current flow is excess, through this fuse will blow off and save the appliance. Okay. Actually, when the fuse is blown off in the houses, we curse it, like we say, oh, why it is gone. Actually, the fuse serves the good purpose. It saves the other appliances from burning. Okay. Next, in case of electric bulb, filament of an electric bulb, you might have noticed inside an electric bulb there is a small filament. It is made up of tungsten. Tungsten is having high melting point. Okay. Next, in heating appliances, they use nichrome wire in heating appliances, whereas resistance is also high and specific resistance is also high for nichrome wire. Hence, it is used in heating appliances. Cleared? If any points you would like to learn more, please comment in the comment box. We'll check out whether we can make more videos on the particular point. Okay. On moving to the concept of electrical power, we learn the important points related to Gpstr exams and for TET. Electrical power is defined as the rate at which the electrical energy is supplied by the source. Okay, so it is written by the formula P is equal to W by T. This W stands for electrical energy. So even though they did not mention anything about electrical energy in the syllabus, it's understood that we have to learn to focus on this electrical energy also. Okay. So electrical energy, this is the expression for electrical energy. W is equal to Q into V. W stands for electrical energy, Q stands for charge, V stands for volt. Okay. And in place of Q, if you write Q, can also be written as I into T. Okay, in particular time when the current flows. So substituting that, we will get this formula W is equal to Vi into T. This is also another formula, and we know that V is equal to IR, and substitute the value of V here and we will get the next formula. Instead of V, we write I into R, so you will get I square R T. And this, for the same formula, instead of I, you substitute I is equal to V by R. We get I is equal to V by R from Ohm's law. If you substitute that, we will get the next formula. W is equal to V square T by R. So these are the formula related to electrical energy. And the commercial unit of electrical energy is watt. Usually we use watt into second. We usually use in practical unit as watt hour. Okay, SI unit of power is watt, whereas commercial unit is watt into second. Practical unit is watt into hour, watt hour. Okay. Moving back to power, P is equal to W by T, and substituting this value of W is equal to VI into T in this formula, we get P is equal to V into I. T will cancel, and substituting this value VI into T. And for the same formula, if you substitute the value of I from Ohm's law, that is I is equal to V by R, we get the next formula P is equal to V square by R. And for this formula, if you substitute the value of V from Ohm's law, we get P is equal to I square into R. All this formulae we have to remember in order to solve the numericals. Okay. The SI unit of power is watt, and it is also written as volt into ampere or joule per second. And 1 watt hour is equal to 3600 joule. Please remember these values. 1 watt hour is equal to 3600 joule. 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joule. And household consumption of electricity, in this concept, how it is calculated, the cost of electricity for the household purpose, it is calculated as electrical energy in kilowatt hour into cost per kilowatt hour. Okay, this numerical was given in the model question paper. Let's try to solve. We have taken a short form. While revising the question paper, we'll learn detail. In a short form, I would like to tell you here. What all given? It was given as power is equal to 400 watt. You convert that into kilowatt, we get 0.4 kilowatt. Time is given as 8 hours per day, and the cost is given rupees 3 per kilowatt hour. We have to calculate for power consumption of 15 days. Okay, using all this data given, let's calculate. We know the formula. If power and time is given, to calculate the electrical energy W is equal to P into T. On rearranging this formula, so substitute this P value is 0.4 kilowatt into 8 hours. So you will get 3.2 kilowatt hour, and cost is 3 rupee for 1 kilowatt hour. So for 3.2 kilowatt hour, when you multiply with 3, we will get 9.6 kilowatt hour. That 9.6 kilowatt hour is per day. For 15 days, multiply this 9.6 with 15, you will get 144 kilowatt hour. Okay, cleared? I hope we have almost covered few important topics related to electricity. In the following classes, we will continue this concept. So all those who have not subscribed to our channel, please do subscribe for all the videos we post here. And if you like this video, please give a thumbs up, so that at least we'll come to know that you like the class. Okay, so don't forget to share for your friends, so that at least some will be benefited, okay, by watching this video. If you have any issues related to this topics, you can comment in the comment section. And if you have asked for biology classes, in the following days you can expect biology classes also. We'll try to solve the question paper, model question paper, once we complete at least half of the syllabus. So you will have some kind of interest in that to solve. Okay, thank you so much for your support. Stay tuned, give a thumbs up, subscribe to our channel, support us and share. Thank you.